so this is the second part of section 2.2. We're talking about different ways to solve a quadratic equation, correct? And let's take a look at the quadratic equation. The form is ax squared plus bx plus c equals 0. This is a quadratic, the quadratic equation. That makes sense? Okay. So the quadratic equation, a is the coefficient of x squared. This is called the linear term. This is called the quadratic term. This is called the linear term and the constant. All right. So when we were solving quadratic equations the other day, we learned how, the first way we learned was, does anybody remember?
Factoring.
Factoring. We used the zero product property. So very good. So we did factoring, zero product property. The second way was square root property. The third way,
Completing the square.
okay, and completing the square was by far the hardest. However, it's the one that works all the time. Square root property, you have to have it in a certain form to use it, and factoring, you got to have it in a certain form to use it. So completing the square is the only one that works all the time. Now, I'm going to suggest to you that you learn the quadratic formula because it is a lot easier than completing the square. It's quicker, but it doesn't make as much sense if you're theory-wise. So, how do we get the quadratic formula? What I'm going to show you is how we get it, because you kind of need to know where it comes from. Okay? The quadratic formula is what happens is we take and we complete the square of this. All right? So just remember, let's talk about completing the squares because that would be a good review. What do we make sure first when we complete the square?
A is 1.
A is 1. So we're going to divide everything here by A. You got that? Okay, so now we have x squared plus b over a x plus c over a equals 0. Does everybody understand that?
Mm-hmm.
Okay. Then what do we move?
C to the right side.
Okay, we move c over a, the constant, to the right side. So now I have x squared plus b over a x equals a negative c over a. Correct? Lila, you with me?
Yeah.
It makes sense. Now what do we do?
You will have to double the denominator.
Okay, and square it, right? So we're going to take half of the middle term and square it and add it to both sides. So we're going to double the denominator, so it's b over 2a, and we're going to square it here, and we're going to add it to both sides. Does everybody see that? Mathematically, it's a lot easier with numbers, isn't it? Okay, now we factor this. I don't know if you know how to factor this, but that's x plus b over 2a quantity squared, correct? It's just this, the square root of this, and the square root of this, right? And then it's quantity squared, this side matches this side. We good, Sophia? Okay. Over here, we're going to have to do a little bit of math. If we square both sides, or both of these, we get b squared over 4a squared. Does everybody understand that? Is?
Yeah, I get that.
Okay, so I'm just going to bring this down for now. I'm going to work over here because we got to get a common denominator. Looks like to me that the common denominator is 4a squared. Is that what it looks like to you?
Mm-hmm.
Yep.
And so I multiply the c times what, 4a? So I get a negative 4ac because it was negative, and right? And over here, that one already has it, correct? All right. So I'm going to play again with it a little bit. I'm going to switch these two around because this one's negative. So and I'm going to put them over the same denominator. So it looks like this. Are we good? So far, so good? All right. So now I'm going to take the square root of both sides. Now remember, the square root property says that when you take the square root of both sides, you have plus or minus, correct? So if I take the square root of the top, that's the square root of b squared minus 4ac. And on the bottom, I get the square root of 4a squared is
4 or 2a.
2a, right? And now I'm going to subtract this fraction to that side. So x equals, and when I subtract, I'm just going to say a negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Does everybody agree with that? Do you agree with that?
Wouldn't the square root of b just be b? or is that in the next
No,
step?
you have to do the whole quantity before, you can't do it piece by piece. And now, since they have the same denominator, I'm gonna put them together. So I get x equals, negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, my fast furry friends, is the quadratic formula. You can look back there. Where is the quadratic formula? It's on the wall somewhere. It's right behind the divisibility rules up there. Yeah. On there. Understand something. The quadratic formula and the quadratic equation are two totally different things. The quadratic formula solves the quadratic equation. Do you understand that? Quadratic formula solves the quadratic equation. Okay. Remember that one we had the other day, number 25?
Mm-hmm.
Okay, we know the answer to that, don't we?
Yeah.
Okay. Let me show you the difference in using the quadratic formula and the quadratic equation. So 25 is this. 7x squared minus 5x plus 2 equals 0. That's it, right? Okay. Now, if you guys remember from Algebra 2, what is b squared minus 4ac called? It starts with a d. Okay, it's called the discriminant. And the discriminant tells you a lot about the root because it's underneath the square root, right? So if the discriminant is negative, you're going to have an imaginary number. Does that make sense? Because it's underneath the square root. If it's positive, you're just going to have a real irrational root. And if it has a perfect square underneath there, you're going to get a real root, a rational root. Okay, so you can have real, irrational, real, rational, and complex, right? All based on the discriminant. All right, so taking a look there in this formula, what is A?
7.
A is 7. What is B?
-5.
And what is C?
2.
Okay, so if I was to do the quadratic formula, I get x equals. By the way, you have to put x equals because that's what you're solving for. That's what the quadratic formula does. It's solving for the roots of this, right? For the solutions of this. Remember, like factoring solves for the roots, you put them in square root signs, or excuse me, put them in set signs. Same here. Okay, so x equals a negative b, which happens to be positive 5, right? Why?
Because it's a negative b, so you know you need to.
Okay, so it's the opposite of a negative 5, right? And so a negative 5 quantity squared minus 4 times a, which is 7, times c, which is 2. All over 2 times a, which is 7. Correct?
Mm-hmm.
So I have 5 plus or minus the square root of 25 minus 56 all over 14. What's 25 minus 56?
-31.
Negative 31 over 14. We gotta poke an eye out, right? When we poke an eye out, we have to separate it. Why?
You have to have a real and imaginary part.
Alright, you gotta have real and imaginary part. Look at that. Would you look at that? There are your two roots. Now, tell me that wasn't quicker than completing the square.
Mm-hmm.
Yeah.
It was quicker than completing the square. Do you see the advantages of the quadratic formula? Okay. What happens when you get something like this? This is number 38. Can you use the quadratic formula on that?
Yeah.
You can't?
Yes.
You can. Is it the quickest way? Not necessarily, no, because you could just factor a 10x out, right? But I'm going to go ahead and use the quadratic formula just to show you that it's possible. What's A?
50.
What's B?
20. Negative.
What's C? All right. So x would be a negative b, which is 20 plus or minus the square root of 20, negative 20 squared, which I believe is 400, is it not? Times 4 times a, which is 50, times c, which is 0, right? What happens over 2 times a, which is 2 times 50, right? What happens to all this?
Cancels out.
It cancels out.
Just 0.
So I have x equals 20 plus or minus, this is 0. The square root of 400 is 20, isn't it? Over 100, right? So I have 20 plus 20 over 100, which is what?
40
Is
or
it
4
still a
tenths,
square root of, or no?
which is 2.
Oh, no, the square root of 400 is 20, so
Oh,
it's gone.
Yes.
Okay. So that'd be 4/10. I believe that is 2/5, correct?
Yep.
And then you have 20 minus 20 over 100, which is?
0.
So my two answers are 0 and 2/5. Even though it's not as quick as factoring in this case, it still works. Quadratic formula and completing the square works on all equations. Factoring and square root property, they have to be in the correct form, don't they? So that's why quadratic formula is so popular. My advice to you is to use quadratic formula all the time, because by the time you figure out if something is factorable or not, it might take you the same amount of time just to do the quadratic formula. That means you have to memorize the quadratic formula. So if I ask for the quadratic formula on a test or quiz, you have to tell me x equals. The biggest mistake that students make is they put this. That is not a formula. That is an expression. This is a formula. Okay? The whole thing. Do you have questions? Do you have any questions on the assignment while we're talking? 22. Okay, 22 says solve by completing the square. So am I still in the video?
Yep.
22 says x squared minus 5x minus 2 equals 0. Okay, the nice thing about this is a is what?
1.
A is 1. Okay, so we're just going to move the 2 over. So I have x squared minus 5x equals 2. What do I add to both sides?
3.
I haven't heard the answer yet. It doesn't mean it didn't happen. I just didn't hear it.
2.5 squared.
Okay, I'm going to take 5 halves squared. I take 5 divided by 2, right? Go half of 5, which is 5 divided by 2, and I'm going to square it. I don't necessarily like working with decimals. There are times that I do, but I always start with a fraction, or usually try to start with a fraction first. So when I factor this, it's x minus what? 5 halves, quantity squared, and I go equals 2 plus 25 over 4, is that correct? So now I'm going to get a common denominator of what? 4? Okay, a common denominator of 4 makes the numerator of the first one what? 8?
Yep.
Okay, so I get 33 over 4. The reason I don't like decimals is because when you take the square root of something, sometimes you get not a good answer. Now I can take the square root of both sides here, plus or minus the square root of 33 over 44, or excuse me, over 4, x minus 5 halves. Sophia, are you good?
Yep.
Okay. So if I break this up, it's plus or minus the square root of 33 over 2, correct?
Yep.
Because the square root of 4 is 2. And then x minus 5 halves, and I can put them together. X equals positive 5 halves. If I bring it over, it becomes positive, plus or minus the square root of 33 over 2.
Could you put the whole thing over to like?
Yep.
Okay.
Why?
Because
Because
there's
there's no I.
denominator.
There's no I. And then it has a common denominator. If it has an I, you got to keep them separated because we got to have a real number part and an imaginary part. But if it has no I, it can be put together. Yeah.
I have a question on 10 and 14.
Okay, 10. Looks like to me 10 is the square root property. Is that correct?
Yes.
Because that's what we started with. Okay. 9a squared minus 12a plus 4. I'll get you started, Izzy, because I think once I get you started, you'll be able to. This is a perfect square, Izzy. How do I know? 9a squared has a perfect square root, 4 has a perfect square root. So 3a times 4 is 12. No, right? But let's see. 3a plus 2, no, 3a, and this is 2. 3a times 2 is 6a, and double it is 12, so it's a perfect square. So in other words, we can factor this as 3a minus 2 quantity squared equals 9. Now you use the square root factor, Izzy. Take the square root of both sides. You're going to have to poke an eye out, right?
Yep.
Okay. And then 14 was the other one?
Yeah.
14 is x squared plus 3x plus blank equals quantity x plus blank squared. Okay?
I was thinking maybe the first one could be 1/2.
Well, it's this squared.
So,
So this,
3
excuse me,
over 2.
3 over 2, because you gotta take half of it and square it. So this would be, so then when you factor it, this would be 3/2. Now, I'm sure at the back of the book, they have 9/4, don't they, there?
I don't know.
Yeah, they'll square that as 9/4. I don't ever, I prefer this, so if you have this, I will count it right. I will count both of them right. I prefer this so you know how to factor it. That's my opinion. Okay? All right, I think we'll let you work then, right?